In this tutorial, we will be discussing colligative properties and Raoult's law. Adding a solute to a solvent modifies the properties of the pure solvent. These changes in pure solvent properties are referred to as colligative properties. Colligative properties depend only on the number. Note that the number of the solute particles relative to the solvent particles in solution, and not the type or kind of the solute particles. So what that means is if we have NaCl dissolving in water, we have one Na and we have one Cl that's being broken apart. Whereas if we have CaCl2, then suddenly we have one Ca, but we have two chlorines there. So therefore there's going to be a bigger change with CaCl2 because of the quantity. So there's three different colligative properties we're going to discuss over the time. Raoult's law is the one depending on this one, and it's the vapor pressure, and it decreases when a solute is added. Melting point depression, the temperature decreases for the melting point when you add a solute, and boiling point elevation, the temperature rises. Raoult's law compares the vapor pressure of a solution to the vapor pressure of a pure solvent. Notice this little circle up here. That's meaning that it's pure. Vapor pressure of water of a solution depends on the number of water molecules per solute molecule. So if you look at these pictures down here, the pure solvent here is in dynamic equilibrium, meaning the molecules that are forming into gas and the molecules that are turning into a liquid are happening at the same rate. Once you add a solute to it, notice the red beads here, it's pulling more of the solvent down, so therefore it's creating more of a solvent in a liquid form than it is in gas. Less is escaping. Now, mathematically speaking, because the mole fraction of a solvent is always less than 1, the vapor pressure of a solvent over a solution is always lowered when you add in the solute. Vapor pressure of a solution is given by Raoult's law of the pressure of the solution is the solvent mole fraction. Notice it's the solvent and not the solute. And the initial pressure without anything in it. So let's do a practice one of these. Assume a solution containing 62.10 grams of ethylene glycol and 250 grams of water is ideal. What is the vapor pressure of water over the solution at 30 degrees? Well, they've given you the vapor pressure of pure water of 31.8 millimeters of mercury. We need to figure out the mole fraction of the water. So that means we need the moles of the water over the moles of the water and the moles of the ethylene glycol added together. So that means we need to convert both of these to moles. So 62.1 grams. They've given you the molar mass of ethylene glycol right there is 62.1. We're going to put 62.10 down on the bottom because that's the molar mass. So we have 1 mole of the ethylene glycol. For the water, 250.0 grams. The molar mass of water is 18.02. We figure that out by looking in the periodic table. We have 2 hydrogens and 1 oxygen. We divide that out and it comes out to be 13.9. So, the mole fraction of just the water is the moles of the water, which is 13.9, over the moles of the 2 added together, which is 14.9, which comes out to be 0.933. So we're looking for the pressure change. So the pressure of the solution is equal to the mole fraction of the water times the pressure, the vapor pressure of the pure water. Multiply those together, and the pressure of the solution comes out to be 29.7. Now that's a non-electrolyte. That means that the ethylene glycol stays as one group. It doesn't break up. It doesn't dissociate when it gets into water. So what happens when it does dissociate? That's an example here. Determine the mass, weight for weight percent of calcium chloride given that the following information. Vapor pressure of the calcium chloride solution is 81.6 millimeters of mercury. Vapor pressure of pure water is 92.6 millimeters of mercury. And we have 1 mole of water. Okay, so notice that we have calcium chloride here. Calcium chloride is an ionic compound, meaning that it's going to break into 1 mole of calcium for every 2 moles of chlorine. So when we're trying to determine what's going on here, first thing we want to do is figure out our mole fraction. So we have the vapor pressure of the solution is 81.6. We don't know what our mole fraction is. That's what we need to figure out. 92.6 is pure water. First thing we want to do is divide that out. Divide both sides by 92.6, and it comes out to be 0.881. That means that's the moles of water over the moles of the solution. In the solution we have water, we have the moles of calcium, and we have the moles of chlorine. But there's a little bit of a trick here. They tell us that we have 1 mole of water, which is fine. Calcium chloride, we have 1 mole of calcium. We have 2 times that of chlorine because of this up here. So what we really have, 1 mole of water on the top. On the bottom, 1 mole of water again, and 1 times whatever that is, and 2 times however much we have of the calcium chloride. So we actually have 3 times the amount of moles from the calcium chloride. So let's rewrite this. I'm just going to leave it 3x, x being the moles from the ions. Because remember, it's the quantity of ions, not necessarily the amount that was actually added. So I'm going to multiply both sides by 1 plus 3x. I'm taking out the words moles of H2O here just to simplify things mentally. So let's distribute the 0.881. X is equal to 1. We're going to subtract both sides by 0.881. And that comes out to be 0.119. We're going to divide both sides by 2.64 to get x by itself. So that means that 0.045 moles is if we had 0.045 moles of calcium and 0.090 moles of chlorine. We want to know how much the mass is altogether of CaCl2. That's as if we were to put CaCl2 0.045 moles of that compound in there. The actual question is asking for the weight percent of that calcium chloride. That means we need to figure out how many grams are in 0.045 moles. So I'm going to move it up here so I have more room. I need to figure out the molar mass by looking on the periodic table. We have 1 calcium and 2 chlorines. That comes out to be 110.99 grams. That's 5.00 grams. We have 1 mole of water. Which once again is 18.02. So 1 mole is on the bottom, 18.02 grams are on the top. Alright, so if we're figuring out the percentage by weight, 5.00 grams over 5 plus 18.02 times 100. That comes out to be 21.7%. That was a rather difficult one, but remember, when you have an ionic compound, you have to break it down because it's the number of ions that matters. And that's why we went from just having 1 compound here, like in the previous question, we didn't have to worry about that because there was only 1 thing, it didn't break down, to having 3 different ions being involved. And that's Raoult's property, Raoult's law.